Kia ora tātou, it's Bill here. I want to look at serial data communications. We want to send some data from our microcontroller through this USB cable to our computer, for instance. Now, what we're going to have a look at is on this left-hand side, we've got a diagram here. We've got the Mega 328 microcontroller. It's got this thing, a USART, universal, synchronous, asynchronous receiver transmitter, and it connects to 2 pins on the microcontroller. We're going to look at today at the transmit function coming out of D1. It goes through the CH340 chip, which is on the underside of the nano board, over the USB cable to the USB interface on your computer. And then there's some software, a CH340 driver, and we'll need some sort of program on our computer to communicate with the microcontroller, in this case, receive data from it. Now, there are a number of different programs around. PuTTY's quite a good one. I like Terraterm because it's quite robust in terms of its communications, and I can reprogram my microcontroller without having to reset my terminal program all the time. So I've got Terraterm started. I'm going to connect serial communications. I'm going to check to see which port my CH340 is connected to. And then click on OK. Now I've got 4 switches here, and I'm polling each of those switches. So if I look at my code, here's my polling code. First switch, send message 1. Second switch, press send message 2. Press the third switch, send message 3. Fourth, message 4. And then after each switch is pressed, we wait until the switch has been released before we continue polling again, just to make sure there's no debounce and we don't detect multiple key presses. So I'm going to do is I'm going to press the first switch, and it's going to say, it's going to send the number 1 and the message COMSTx2 rocks. I'll send that again, and you'll see that the number it's sending is actually in binary, and it's a little sequence number. Every time I send a message, it sends a new number in the sequence. Second message, what's up? And third message, all good. Now, the fourth message is I'm sending the alphabet multiple times. There we go. And I'll get into why I'm doing that in a moment. Let's have a look at the code and see what's required to get serial comms set up. We need to know the baud rate at which we're sending information. In this case, it's 9600 baud or bits per second. This number is then converted using this formula into a number and stored in the register to set up the USART. This equates to 103. We go down, I've got some functions here, and I've got some memory set aside with some variables in it. So let's have a look at this, say message 2. Message 2 is what's up. So what we've got here is we've allocated an array of chars. Now char's an 8-bit variable. So I've allocated 7 bytes of memory with this. Now we notice that my message was up is only 6 letters, but it actually allocates a 7th when you do it in this way, and that puts the null terminator or the number 0 in there. COMSTx2 rocks, all good. So in all good, we got 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 characters. That means that our message 3 is actually 9 bytes long in memory. Have a look up at TX buffer here. I've allocated an array, memory and array, and it's 10 bytes long, which means that it can only store a message which is 9 characters in length. If you overwrite the null termination, the 0 at the end of your array, you can get into all sorts of trouble. Let's scroll down and have a look at the send message function. So we're sending the first message. Note that when I'm sending message 1 is actually a pointer. It's not clear in C sometimes what it is you're sending, but because message 1, what this is it's creating a pointer called message 1, which is the address of the first memory location where this data is stored. So I go down to send message, and here it's quite explicit that what we're receiving is in fact a pointer. There's my counter, which counts each message which is sent. And then I use some functions. The first function is U2A, which is an unsigned to an ASCII. So all our characters are stored in ASCII code. And so we've got to convert the number which is in TX message count, into ASCII code and store that in buffer. And I'm saying to do it in base 2 or radix 2. If I want a base 8, I put 8 there, or base 10. What happens then is we send the string, which is TX buffer, which of course has got our number in it, to our next function. And then after that, I send a space, and then I send the message, and then I send a new line and a return. So what we're doing here is we're breaking out our text into individual parts and sending them one part at a time. I could, of course, use the printf function. Now, I'm not using the printf function because the printf function is pretty heavy on memory in terms of storage, so it takes up a lot of our flash. And if you don't need all the functionality that's in printf and you only need a little bit of functionality, then consider breaking it up into separate little functions and using the different functions. Now, U2A, of course, is in a library. Scroll back up to the top and I'll see that U2A is in a library. So that's for the unsigned 16-bit. To an ASCII, of course, is an int2a, which is the signed. There are plenty of functions in the string library that you can use as well. So what happens when you actually put a string, remembering that there's no such thing as a string in C, it really is just an array of chars, which is null terminated. So this I'm sending it the pointer to our array, and what I'm saying here is that we loop through the array until or while it's not 0. So until we get to a 0, or while it's not 0, we're looping, and then we're transmitting one character at a time. So let's jump down into the character. Here's the character. So we're taking in, we're passing the dereferenced. You'll notice we're dereferencing the pointer and passing the actual data. So we're receiving the actual data here into this function. And then what's happening is we're waiting. While this is 0, we're waiting. And let's have a look at the data sheet to see what's actually going on here. I'll get the data sheet, and I've gone to section 20, which is all about serial communications. And I'll just have a look at this transmit functionality in the USART. So what we've got is we've got a register, and when you put something into this register, automatically it goes into the shift register and then starts sending it out bit by bit, adding parity if required. Now, what we're doing here is we're saying that while this is 0, just wait. And so what happens is this bit here and this register is set to 1 when it has finished sending all of the bits. Because it's sending them serially, it takes a little while to do that. And so when it's finished sending them, copy the data into this register here, and then this, once it's copied in, will automatically push it into the shift register and send it. So that's how this function here works. So that's what's happening with our code. I'll just put my little Terra turn back up, and I want to have a look at this particular forth when I'm sending this long message. Now you'll notice that it takes a little while for the message to appear because it's slow at 9600 bits per second. This is a long message, it takes a little while. The effect of that is that I'm actually polling my switches. So if I press my switch twice, rapidly, it only sends the message once because it's blocking. You'll see that this code here is waiting while it's 0, and it won't move on. So what's happening is it's sending, all of the data for each single one of these characters sequentially, and that takes quite a while, and so it's blocking. And that means, of course, that our polling up in the main loop is not happening at the same rate as we might want it to. So our microcontroller is not as reactive and responsive as it might be. So I press that twice, it's only sending the message once. Okay, now if I can press some of the other messages twice and it will send them because they're only short. So if I want to increase and improve the speed of this system, there are a couple of things I could do. The first thing is I could use interrupt-based system, so that an interrupt is triggered when it's finished sending that byte and gets the next byte to send, so I don't have to wait for it. So an interrupt is quite a good way of doing it. Another way is to slightly increase the speed of our system. So what I'm going to do is I'm going to look at my 9600 and think, what are some other speeds of which I could use? So come back to my data sheet here, and it's got examples of baud rate settings. And it all depends on the frequency of the microcontroller. Our microcontroller is using a 16 megahertz crystal. So I'm going to look for the table that looks at 16 megahertz. And here it is. Here's a 16 megahertz. Now there are two columns that we can look at here. This is for normal speed, and this is double speed. We're not sending at double speed. And we're sending at 9600. Now I did mention that this parameter over here in the code, that when we calculate it works out to be 103. Well, there's the 103. If we store 103 into this register, then we're sending at 9600 bits per second. You'll notice that there's an error of 0.2%. Now what that means is that our data will not be sent at exactly 9600, but will be sent at 0.2% different to that. Now, serial data communications are reasonably robust and can handle some small error percentages. That's fine. But if we want something that's really a lot more accurate, then we might use a crystal in our microcontroller, such as 18.432 megahertz, because here you'll notice that all of these are 0% error. So some crystal frequencies, and there are other listed in this table, that are really quite good for sending a lot of serial data at high speed with very little error or no error at all. You'll notice, for instance, if I wanted to send it 230.4 kilobaud, then there's an 8.5% error. So what I'm going to do is I'm going to up my speed of my system to 19.2. So I'll go to my code and I'll send that to 19.2, 19,200. It's a standard baud rate. I will compile that. It's compiled, and now I will upload it. I'm going to upload it. There we go, that's uploaded. And what I'll do is I'll have a look at TerraTerm, and I'll just send this message again. Oops. You'll notice that sending these messages, I'm getting garbage. Okay. Now that is because serial data communications requires both ends of the system to understand several parameters. And in this case, the parameter I've changed is the baud rate. So I need to go to setup in TerraTerm, serial port, and I will change this to 19.2. There's my new setting, and I'll just see what happens. There we go. I'm not actually getting, it's still not quite right. I'm going to restart TerraTerm and just make sure that it has reconfigured itself. I choose my COM port again. Now, just double check my setup is 9600. Let's change that to 19.2. New setting. We'll just try this again. There we go. And there's the message. So this is coming through a little bit faster now than it was before. A double press, you'll notice that I'm getting two messages. Now, I hope that helps you understand a little bit about serial data communications. We're going to use serial data communications in some of the future tutorials. Hey, you have a good one. We'll see you around.